Hi students, this is Mr. Yao. Today we're going to talk about 8.1 where we will learn about volumes, how to find volume of different shapes and how to find parts from the volume. So first let's actually review some volume that we have learned before. Let's start with a rectangular prism. For this one, in order to calculate the volume, we are going to do length times width times height, which in other words is the base area times the height. 4 times 2 times 1.5, that is going to be 12. Don't forget a unit, meter cubed. Number 2, that is a triangular prism. It's still the same idea. It's the base area times the height. The base area for a triangle is 1/2 times 7 times 10, 1/2 base times height for the triangle area, and then times the height for the whole thing, which is 5. That is going to be 175, don't forget a unit, inch cubed. Number 3. This, if you have a look, is actually a rectangular prism. Then take away these two little parts. You can extend them for you to see. Take away that part, and also take away the part that's on the other side. Right, so it's gonna be the whole thing, 5 times 4 times, the height is 3 and the 1, so times 4, then minus 1 times 1 times height for these two little sticks is 4, and there are 2 of them. So that is going to be 72, no unit. Next, let's have a look at a cylinder. You can go ahead and guess which one do you think actually contains more soda. And after that, we know a can of Coca-Cola contains 12 ounces. Guess how much soda in each glass right now. Let's move on, see if you guessed right. Okay. And in order for us to actually exactly know which one is more, which one is less, what kind of information will you need to know to solve the problem? And which will be the easiest? Is it the radius? Is it the diameter? Is it the circumference? So pause and think for a second. Hopefully you have thought about it. To me, I think the diameter will be the easiest because for the radius, you actually need to exactly find out where the center is. For the circumference, the string is kind of hard to control for you to go around, all the way around. So a diameter is actually the simplest because diameter is also known as the longest chord. So all you need to do is move around inside the circle until you actually get the biggest length. That ought to be a diameter. Now these 4 shapes, what do you see that they have in common? Pause for a second here and think through. Okay, you might say they all have solid line and dotted line. Yes, because they're all 3-dimensional shapes. But something I want to emphasize on is they all have the same kind of idea about calculating the volume, which is they all have a base. Which is why the volume for a shape like this is always going to be base times height. And it's the base shape that is actually constantly changing. So here's the formula for the volume of a cylinder. For a cylinder, the area of the bottom, which is the base, is actually pi r squared. Formula is V equals pi r squared h for a cylinder. Now let's have a look at how to calculate the volume of a cone. When you're watching the video, decide how many cones did it take to actually fill the entire cylinder. If you watch the video, you should notice it takes 3 cones to actually fill an entire cylinder, which is why the formula for a cone is related to the volume of a cylinder. So it's going to be 1/3 pi r squared h. The pi r squared h is the cylinder, and 1/3 is the cone. Now let's have a look at the volume of sphere. Watch the video and decide how much of the cylinder does the sphere actually fill. If you have a look, it actually fills up 2/3 of the cylinder. So let's actually come from the formula of a cylinder, pi r squared h. Something we do know is this sphere is actually the same height as the cylinder, which may not be called a height. Basically, that means the height is the diameter. Basically, that means the height is the diameter, which is actually twice the radius. So let's actually replace that. Replace h with 2r, so pi r squared times 2r, and it's filled up with 2/3 of it. That put all together is going to give you the circle formula, which is 4/3 pi r cubed. Next, volume of a pyramid. Pyramid is clearly related to prism, so watch the video and decide how many pyramids did it take to fill the entire cube. Okay, so as you can see, it takes, again, 3 pyramids to actually fill up the cube. So the formula is related to the cube again, which is 1/3 length times width times height. It could be a square or it could be a rectangle. It just depends on the pyramid. And it's kind of how cone and cylinders are related. It's by the fraction 1/3. Next, based on the formula for the volume of a pyramid, what is the formula for the volume of a triangular pyramid? And that is 1/3 the base area times height. Is related to a triangular prism. Now let's have a look at how we can use these to solve some examples. Number 1, we see it's a triangular pyramid. The volume is 1/3 the base area times the height. The base area is a triangle and is actually a right triangle. So we can just use 1/2 base times height. It's going to be 1/3 times 1/2. The two sides of the triangle is 8 and 6 times 8 times 6. Even though you see this 10, when we try to calculate the area of a triangle, we need base and height. And they need to form 90 degrees. And the 90 degree is right there, so we just use 8 and 6 for the area of the base triangle. And times the height for the whole thing, which is 7. And after calculation, the answer answer should be 56 mile per cubed. Next, example 2. This time the radius is not given, diameter is given. We need to identify the radius first, which is 7 mile. And the volume, since it's a cylinder, would be pi r square h. Pi times 7 squared is 49, and then times 11. Something to be careful with, the question says leave your answer in terms of pi, but also round to 2 decimal places. So first, we are going to keep the pi, which means you just need to calculate the 49 times 11. That's going to be 539. Pi, don't forget the unit, is mile squared. And then we are going to actually calculate what exactly is 539 times pi. If you don't know where to find the pi button, it's actually on top of this little button in the calculator. So you're going to press second and then press that button. That's how we find pi. And it's going to be 1693.32 mile cubed. Example 3. This time is a sphere, so 4/3 pi r cubed. 4/3 pi r is 5 cubed. So it's going to be 500 over 3 pi, or if you actually try to replace the pi, is going to give you 523.598, so it's going to be 60. This time is a cone, so 1/3 pi r square h. 1/3 pi, the radius is 12 squared because the 24 is the diameter. The height is 20. And if we actually keep the pi, that is going to give you 1152 pi, which if you replace the pi with the actual number is going to be 3619.11 yard. That's example 4. Example 5. Bottom is a rectangle, so 1/3 length times width times height. So 1/3 length is 11, width is 6, height is 11, and that is going to give you 242 kilometer cubed. Next, number 6. See a question like this, you're going to be like, wait, what is that dotted line doing there? The dotted line actually indicates there's some other shape inside. And for this specific case, it's actually a cylinder taking away half of a sphere. The volume first is going to involve the cylinder, so pi r squared, which is pi times 3.3 squared, then h is 7. After that, you're going to subtract 1/2 of a sphere, because this is a semi-sphere. So 4/3, and the pi. As for the radius, is actually the same radius, so 3.3 cubed. And for this one, if you put in the calculator, that is going to give you 76.23 pi, 23.96 pi. After subtraction, that's going to give you 52.272 pi. Of course, we still need to actually replace the pi to find the actual number, which is going to be 164.22. And the unit is inch cubed. That is example 6. Example 7. This time is kind of similar, but you can see it's a cube taking away a cone. So the area of the volume is going to be this cube, so 5.1 cubed minus 1/3. The radius is actually not 5.1, the radius is half of that, so it's going to be 2.55. Don't forget the pi. This is squared, and the height is 5.1. After calculation, the answer would be 97.92. Don't forget the unit, meter. That is example 7. Next, example 8. This you can clearly see it's a cylinder. So B is pi r squared 8. The volume actually equals to 128 pi. So now we're going to divide both sides by pi. Well, not yet. I'm going to replace the height with 8. Equals to 128 pi. Divide both sides by a pi. That is gone. And r squared equals 128 divided by 8. That is going to be 16. Square root both sides. R is 4. Don't forget a unit, inches. However, this question didn't just ask for r. This question actually asked for x. And x happens to be 2r, which is 8 inches. That's example 8. Example 9. Volume of a sphere 4/3 pi r cubed equals 523.6. In this case, we want to get rid of the pi by dividing both sides by pi. It's the fraction part that's a bit tricky. You can choose to actually do divide both sides by the 4/3, but that's going to make things more complicated. So instead of dividing by 4/3, we're going to multiply by the reciprocal. So we're going to, in this case, do the same to the right side. We're going to multiply by 3/4. So that is gone, the pi is gone, r cubed equals, and that is going to give you 125. Cube root both sides. R is 5 kilometer. Next, example 10. A cone 1/3 pi r squared h equals 718.38. A diameter is given, but we need a radius, so 7 yard is going to be the radius. 1/3 pi. The r is 7 times 7 squared, and h is unknown, is equal to 718.38. So we're going to get rid of everything, get rid of the pi, get rid of the 49. And again, so the 1/3 like that, instead of actually dividing everything by 1/3, we're going to multiply both sides by a 3. And in this case, that is going to give us h equals 14 yard. That's example 10. Example 11. You can pause here and see if you can find the mistake. The mistake actually is, when we want to deal with cone, is 1/3 pi r squared h. Where exactly is that h? It should actually be from the tip to the center. That is the height. However, for this question, the 15 is right there. So we cannot exactly use that number for volume. But with that number, we actually have a Pythagorean theorem right here. So we can actually get some kind of water, which is, well, after you solve the Pythagorean theorem. Next, we're going to have something called corollary principle. This is basically saying if two solids have the same height and the same cross section, anywhere you put a plane across, you'll see the same area, and they have the same volume. Just like these two pies of coin listed on the right side, the first one is kind of uniformed, and the second one is kind of twisted, but they are still the same for volume. It doesn't change anything. Next, here's a cylinder. What would the volume be if we actually double the radius? So right now the diameter is 4 feet, so the radius is already 2 feet. If we want to double that, that is going to give us 4 feet. So now let's actually calculate the volume and check it out. This is a cylinder, so pi r squared. R now is going to be 4 squared, and the h is 9. After putting in the calculator, that's going to give you 452.39. And if you look at it, it's not actually just being doubled, it's actually being quadrupled. So this is like 4 times the original size. Now let's see if we actually double the height. B equals pi times 2 squared. Double the height is going to be 18. So that is going to be 72 times the pi, which is 226.1, and that clearly is twice. So if you think about it, the formula is pi r squared h. R is being doubled, r becomes 2r, and that part is actually becoming 4r squared. And that is why, if it's changing by r, it's actually being squared. But if it's changing in height, there's no square, so that just stays there. 2 more. Next, 13. This time we don't have any dimensions we can use, so we can only use the formula. B equals, that is a sphere, so 4/3 pi r cubed. And it's saying the radius is being dilated by 1/3, so 4/3 pi times 1/3 r cubed. That is going to be 4/3 pi 1/27 r cubed. Have a look at the original function right here. The 3/4 stayed there, the pi stayed there, the r cubed stayed there. The only thing extra is actually 1/27. So that means the volume is going to be 1/27th the original size. Last one, 14. A cylinder, same idea, B equals pi r squared h. Radius is changed by 2, so pi 2r squared. Height is changed by 3, so times 1/3. That is going to give you 4 pi squared or pi times 4r squared times 3rd h. To compare with the original formula, pi is there, r squared is there, h is there. The only thing that's missing is the 4/3, which is why that is how much the volume is going to change. That is number 14. That is everything. And that is everything for 8.1 volume.